Welcome to the Explainer. Today, we're going to demystify a term that sounds like it's straight out of a sci-fi movie, but trust me, it's very real. Quantum supremacy. And this is way bigger than just building faster computers. It's a fundamental leap that's already starting to reshape our entire world.
All right, let's jump right in. Here's what we're going to cover. First, we'll nail down what quantum supremacy actually is. Then, we'll look at the incredible breakthrough that proved it was possible. After that, we'll explore how it could revolutionize, well, pretty much everything. We'll also tackle the huge security problem it creates. And finally, we'll talk about what all this means for your future.
So first things first, what are we really talking about with quantum supremacy? You hear that term, and it's easy to just think, oh, it's just a really fast computer. But that's not quite it. It's much deeper than that. It's a totally different way of processing information.
At its heart, it all comes down to this one question. Can we build a machine that solves problems that are, for all practical purposes, completely impossible for even the most powerful supercomputers we have today? We're not just talking about being faster. We're talking about doing the impossible.
And there's your answer. Quantum supremacy is that exact moment, that milestone. You know, think of it like this. A regular computer trying to solve a giant maze would have to try every single path, one by one. But a quantum computer, it can kind of explore all the paths at the same time. It's a completely different and way more powerful way to find the solution.
And this right here, this is the magic behind it all. On the left, you've got your classical bit. It's the building block of all our current technology. It's basically a light switch. It's either on or off, a 1 or a 0. Simple. But the quantum qubit on the right, that's more like a dimmer switch. It can be fully on, fully off, or somewhere in between. It can be a 1, a 0, or, and this is the crazy part, both at the same time. That's a superpower called superposition.
But wait, there's more. Superposition is just one of the qubit's superpowers. The other one is even weirder. It's called entanglement. Imagine you have two coins that are magically linked together. No matter how far apart they are, even across the galaxy, if you flip one and it lands on heads, you instantly know the other one landed on tails. That's entanglement. And when you combine that with superposition, you get a machine that can explore a mind-boggling number of possibilities all at once. That's where the power comes from.
So this all sounds amazing in theory, right? But how do we know it actually works in the real world? Well, back in 2019, Google's Sycamore processor gave us the proof. This was the moment quantum computing jumped from the whiteboard into the real world.
So what Google did was pretty clever. They didn't just ask Sycamore to solve any old problem. They gave it a task that was specifically designed to be an absolute nightmare for a regular computer. Think of it like trying to find one specific grain of sand on every beach on Earth. It was the perfect test to show off what a quantum processor could uniquely do.
And here's where it gets wild. To put this challenge into perspective, they estimated that the world's most powerful supercomputer at the time would have taken 10,000 years to finish that calculation. That's longer than all of recorded human history.
So 10,000 years for the supercomputer? How long did it take Google's Sycamore? 200 seconds, yep, a little over 3 minutes. A task that would take a classical machine an eternity was done in less time than it takes to brew a cup of coffee. I mean, that is just an incredible demonstration of raw power.
And that's the key thing to remember. The problem itself wasn't practical. It wasn't designed to cure cancer or predict the stock market. It was a benchmark, a test specifically created to prove a point. And boy, did it prove it. This was the moment the starting gun for the quantum age really fired.
Okay, so we've proven this incredible power exists. The big question now is, so what? Where do we go from here? Well, this isn't just some cool science experiment. It has the potential to completely change our world.
Let's start with medicine. Right now, discovering new drugs can take decades and cost billions. It's a lot of trial and error. But imagine if a quantum computer could perfectly simulate molecules, letting us design new medicines from the atom up. We could create personalized treatments based on your unique DNA or design brand new materials that could change everything from energy to transportation.
And it doesn't stop there. In finance, these machines could model the entire global economy, maybe even predicting financial crises before they happen. For AI, they could supercharge machine learning, finding patterns in enormous data sets that are completely invisible to us now. They could even solve the world's most complex logistical problems, optimizing shipping routes and supply chains in a way that saves massive amounts of time and energy.
But, with any powerful new tool, there's always a flip side. And the very same power that makes quantum computers so exciting also poses one of the biggest threats our digital world has ever faced.
So here's the deal. All of our online security, your banking, your emails, your private messages, it's all protected by encryption based on math problems that are just too hard for regular computers to solve. The problem is, quantum computers are exceptionally good at solving those exact kinds of problems, which means once we have large-scale quantum computers, most of our current digital locks could be broken wide open, almost instantly.
Now, before you panic, the good news is that people are already on this. The same brilliant folks building quantum computers are also building quantum-proof defenses. There's a whole new field called post-quantum cryptography, and its entire goal is to create new kinds of encryption that even a quantum computer can't crack. It's basically a race to upgrade our security before the threat becomes real. So, let's bring this all back down to earth. What does this quantum revolution actually mean for you? Well, this isn't just something happening in a far-off laboratory. It's going to create a whole new world of challenges, and with them, incredible opportunities.
I mean, just look at this. We are literally seeing the birth of entirely new professions. Roles like quantum algorithm developer or quantum hardware engineer. These jobs didn't even exist a decade ago. It takes this amazing blend of physics and math and computer science, and that's creating a huge demand for a totally new kind of expert.
Now, of course, we have to be realistic. We're still in the very early days here. There are some massive hurdles we still need to clear. These qubits are incredibly fragile and sensitive to errors. Just building and scaling up these machines is one of the biggest engineering challenges of our time. But hey, solving huge challenges is what drives innovation forward, right?
Every single day, researchers are making new breakthroughs. That Google experiment wasn't the end of the story, it was just the beginning. The big takeaway is that this isn't science fiction anymore. The quantum revolution is happening right now. It's going to completely redefine what's possible in our lifetime. So, the only real question left is, what part will you play in it?